Hello, chemistry students. When we last saw each other, you guys were either completing lesson 2.8 or you were about to complete lesson 2.8. Lesson 2.8 really is just a review. This really is your review packet for the test. So what I intend to do, with some potential interruptions from my dogs or cats, is to walk you through a couple of these examples in each of the categories. We'll look at ionic bonds, but with polyatomic ions, covalent bonds, be they polar or non-polar, and look at how it could work on a big sheet like this. Where I don't tell you the type, you have to figure out what the bond is. I'll solve a few of them with you, and then I'll post the answer key for all the rest. When doing ionic bonds, remember, ionic bonds, when you're looking at the name, there are no prefixes. This only applies to ionic bonds, though. Covalent bonds have prefixes. So the name's not going to help you with the subscripts for your lithium and your oxygen. You have to decode, you have to do the crisscross rule. So lithium is a 1+. Oxygen is a 2-. So I would need 2 lithium pluses to balance out my 2- charge. So I have 1 and 2 lithiums, so it's Li2. And yet I only have 1 oxygen, so I'm going to leave that subscript blank. Molecular drawing. You want to alternate your positive and negative charges. So I've got lithium, I've got oxygen, and I've got lithium. Oxygen had its original 6 valence electrons, and then it stole a valence electron from lithium. That got transferred. And it stole this valence electron from that lithium. So that it ends up arranging like that. That makes all of them ions. That's a positive ion. And this is a positive ion because they gave up 1 electron. And this oxygen, because it stole 2 electrons, becomes 2-. You should be able to go backwards. If you have the formula, give me the name. And then give me the drawing. All right? Or from the name, just like the last one, give me the name, from the name, give me the formula. From the name, or from the formula, give me the drawing. All right, ionic bonds, but with polyatomic ions. This right here is a polyatomic ion you need to know. That is carbonate. So I'm not going to try to, that's got a special name. When it's in those parentheses, that's usually a key that it's a polyatomic ion. With polyatomic ions, they keep their original polyatomic ion name. They don't get a new ending. And it's ionic, so sodium gets to keep its elemental name. I don't use prefixes to tell me how many sodium because we're still dealing with ionic bonds, and ionic bonds do not use prefixes. All right, do the same, but here you will have to look up the typical charge on calcium and look up the formula and the typical charge for phosphate. Do not draw them. They're not required on the test. All right, covalent bonds. Covalent bonds do require prefixes in all but one scenario, and this first one will show that one. So from the formula, give me the name. I can see how many nitrogen, and I only have 1. This is the one time you don't need a prefix, is if the first element, in this case nitrogen, has only 1 atom. You keep its name, nitrogen, with no prefix. The second element, will always get a prefix, even if there's only one of them. In this case, there are 3, so it becomes a prefix of tri. And then fluorine, no, fluoride. So it's got the ending "ide," and it's got a prefix here. And if this nitrogen was more than 1, it would need a prefix here. But since it's only 1, no prefix needed. All right, molecule. So again, look at your elements. Nitrogen can bond with 3 different single covalent bonds, and fluorine can only bond with 1 single covalent bond. So I'm going to start with nitrogen as my most versatile atom. And then I could put a fluorine here, a fluorine here, and a fluorine here. Fill in the rest of fluorine's valence electrons, positioning the unpaired valence electron to nitrogen. Then draw, that's a bit sloppy. Draw the covalent bonds. In this case, a single covalent bond from fluorine to nitrogen. So in this case, we have 1, 2, 3 single covalent bonds to 1, 2, 3 different fluorines. All right, try your hand at the rest of these. What did I just do? I did formula to name. So on the polar covalence, let's try, for the example, I'll do a name to a formula. So I'll do this one. Tetrasilicone. So Si4. Decahydride. So that's, remember we have new endings, ide, so that must be hydrogen. And 10 of them. So SiH10. All right, there's your silicone. There's your tetra. Here's your hydrogen. And here's your deca. All right, formula. Most versatile. Hydrogen can only make 1 single covalent bond. Silicone can make 4. So I'm going to start by linking my silicones together. 1 silicone, 2 silicone, 3 silicone, 4 silicone, as my name demands, tetrasilicone. I've got 1, 2, 3, 4 valence electrons. 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 Single covalent bond, single covalent bond, single covalent bond. I have room for 1 bond, 2, 3, 4, 5, 6, 7, 8, 9, 10 single covalent bonds. And I've got 10 hydrogens that need homes. So there we go. Hydrogen, 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 hydrogen. Cool. All right. Now let's try this first one. Hydrogen. Ooh, electronegativity table. I don't have one sitting here at the desk. It's really frustrating. So if you also don't have one, let's go to Google Classroom. So go to Google Classroom. Make sure you're signed in with your school account. Go to your chem class. Go to classwork tab. Go all the way to the bottom. And you will see general info, periodic table, and electronegativity table for the test. Open that up and you will get the document that I've given to you guys before. So remember, periodic table on top, electronegativity values on the bottom. Just remind myself what I need. I need phosphorus and hydrogen. So electronegativity of phosphorus. Phosphorus is 2.1. So yeah, I can't really highlight that for you, but Phosphorus is 1, 2, 3, 4 columns over from the right side, second down. So that's 2.1. Hydrogen is also 2.1. So phosphorus electronegativity 2.1. Hydrogen electronegativity 2.1. Phosphorus and hydrogen are both nonmetals. So the nonmetal plus nonmetal makes me think covalent bond. And then the electronegativity difference, 2.1 minus 2.1, is 0. So that confirms it is covalent. Furthermore, it is non-polar. Covalent. Where did I get those numbers from? Well, if you go all the way to the beginning of this unit, you will see the electronegativity ranges. I fell right here at the 0, and the difference between the large minus small. All right, that gives me the difference, and I'm at 0. Go back down. So, therefore, nonpolar covalent. I got the formula. I need the name. When the formula is already given in an order, stick with that order. There are 2 phosphoruses, so I need diphosphorus tetra hydride molecule, 1 phosphorus, 2 phosphorus, link them together. Now I need room for 4 hydrogens. 1, 2, 3, 4. Single covalent bond, single covalent bond, single covalent bond, single covalent bond. All right, remember, if it is a metallic bond, if you read the instructions, do not try to name it or give me the molecule drawing. I've never taught you how to do that. There's no such thing. They don't really do that. All right, so complete the rest of these, and then check and attempt to do this. Integrate vocabulary in several different pieces of chemistry knowledge. Electronegativity, valence electrons, octet rule. In what way can a halogen, all right, most halogens conform to 1, 2, 3, 4, 5, 6, 7, conform to an electronegativity, Lewis dot diagram that looks like this. How can they ionically bond with an alkali earth metal, such as one that has a Lewis dot diagram that looks like this? Or covalently bond with another halogen, different halogen. Or how can it not bond with a noble gas? All right. Work on that. Check your answer key. Check the answer key I post. Good luck studying, and I will post some more for a new unit very, very soon.